In this video, I want to continue my discussion of what is trigonometry. So I was talking about relationships of triangles within right triangles, and I had drawn this example where I begin with a triangle that has side lengths of 12, 16, and 20, following that Pythagorean theorem relationship that 12 squared plus 16 squared is in fact 20 squared. And then if I were to cut it in half by placing points on the midpoints of the hypotenuse in one of the legs, I create a little smaller triangle that has lengths of 6, 8, and if you use the Pythagorean theorem, you'll find the hypotenuse is 10. And so we have that. So there doesn't seem to be anything fantastic right now, but I want to point out some proportionality that's going on. I just noticed this should say 8 squared. 6 squared plus 8 squared equals 10 squared. So if you were to take any of the two sides and keep them in relationship to one another, you would find out that proportionality holds. So let's take a look at what I mean by examining that with angle A. I'm going to look at angle A right here, all right? And I talked a little bit about what I mean by calling the sides. If we look at the names, if we look at the big triangle, this side over here will be the hypotenuse. If we look at the small triangle, this side over here will be the hypotenuse. Fine. In relationship to angle A, this other leg is what I called the opposite leg, all right? And the little triangle, 8, would be our opposite leg. And then that would mean that the bottom side would be what I'm calling the adjacent side, or the little leg would also be the adjacent side there. So notice that all of those labels are in relationship to the angle A. So what you can find is that if you look at any comparison of any two sides, that proportionality will hold. So let's see, what do I mean? So in relationship to angle A, if I were to look at the opposite side divided by or over in relationship to the adjacent side, for example, what I would find is on the larger triangle, what's true? Well, the opposite side has a length of 16, and the adjacent side, the side next to it, has a length of 12. But if I looked at the smaller triangle, I would see it's 8 to 6. If you examine those two fractions, 16 to 12 and 8 to 6, what you're going to find is that both of those would simplify down to 4/3. All right, so there's this relationship of 4 to 3. If you were to think about that a little bit more, where is 4 to 3? You can actually find it. You can make an even smaller triangle, and I'm going to try and draw that in. If you were to find half of these new lengths right here inside, like that, you can find a little triangle here. I'm going to shade it in, where the lengths would be 4 and 3. And so what that basically means is that the relationship, the proportionality holds. And it holds true for the other sides as well. And what trigonometry does is it exploits this relationship. It knows that for any given angle A in this example, no matter how large the triangle is, the side lengths will be proportional to it. So if we know that, once we know something about a particular given angle and we know the relationships of the sides, we know that no matter what size the triangle is, that same relationship will hold. And we can use that to solve distances and lengths and angles with triangles. And that's basically what trigonometry is. So in the future videos, I'm going to define more what are 3 main trigonometric functions and how we can use those. And luckily, we live in the year 2021. I say luckily because we're going to take advantage of a calculator that's memorized a lot of these relationship values. When I say memorize, I mean it's been programmed in. So we can find these relationships between any size triangle.